And remember, for the unit force, net force equals mass times acceleration is used to define the units of force in terms of the basic units for mass, length, and time. The SI unit or the system of unit of force is called the Newton, abbreviated N, and is in the force needed to accelerate a 1 kilogram system at the rate of 1 meter per second squared. That is since net force equals mass times acceleration, and 1 Newton is equal to 1 kilogram meter per second squared. The equation for weight, the gravitational force on a mass m, which is W equals mg. W stands for weight, m stands for mass, and g stands for gravity, which is equivalent to 9.8 meter per second squared. So let us now solve some real-life problem.
A sumo wrestler weighs 180 kilograms and accelerated downward at 9 meters per second squared in an elevator. If the acceleration is 20 meters per second squared due to the gravity, what is the normal force exerted on the sumo wrestler by the elevator's board? Before proceeding to the actual solving, let us first determine what is asked and what are the given. What is the normal force exerted on the sumo wrestler by the elevator's board? For the given, we have the mass, which is 180 kilograms, acceleration, which is negative 9 meters per second squared since it is downward, and the gravity, which is 20 meters per second squared. Then, we will draw a sketch of the problem as well as the free body diagram. Let us now proceed to the actual solving. First, let us solve for A, or acceleration. For this specific problem, we will subtract gravity with acceleration. We will then have an equation. A is equal to 20 meters per second squared plus negative 9 meters per second squared. Simply add 20 meters per second squared and negative 9 meters per second squared and copy the unit. We will then have 11 meters per second squared, which is our acceleration.